Hello everyone. So let's start with the basics. So in theory of computation, first of all you need to understand what the subject deals with. So it is a subject which studied in branch of computer science and sometimes in mathematics department also, and it deals with the logic of computation, which are referred from simple machines or which are referred to as simple machines. So what I mean to say, if you have some logic and you want to implement this logic on some machines, simple machines, then this subject is going to take care of that. Okay, and this simple machines is called as automata. Okay, so automata is a simple machine which requires some logic to implement the various tasks, and the theory part we will cover in this particular subject. Okay, so I think you understand the importance of the logic of computation behind this theory of computation. There are four pillars which are required to study in this subject. The four pillars are as follows. First is the symbol. What is symbol? Symbol is the basic building block in theory of computation. Okay, theory of computation. Okay, this basic building blocks can either be letter or digit or any other, let's say, alphabet. Okay, so either you can consider letter, alphabet or digit. All this is considered as a basic building block of TOC. It is called as a symbol. For example, small a, small b, small c, capital A, capital B, capital C, and so on. 0, 1, 2, 3, and so on. So all these nothing but symbols in theory of computation. The second pillar is alphabet. So what is alphabet? If you group them, these symbols together, then it is nothing but an alphabet. So collection of symbols form alphabet, and alphabet is represented by the symbol sigma. So sigma is used to represent alphabet. Okay, so the collection of symbols, maybe example is small a, small b. Okay, so this is nothing but alphabet. Okay, third pillar is string. Okay, so symbol is the basic building block. After that you combine this symbol to form alphabet, and after that when you combine the various alphabets together, then it is formed as a string, or it is called as a string. So string is nothing but sequence of alphabet. And what are the sequence? The sequence might be possible as a string of length, let's say string of length 1, possible over alphabet possible over alphabet A, comma B. So string of length is A and B. So this is the string for the particular alphabet A, comma B, and it is length 1. Okay. And finally the last pillar, fourth one is, so after I have not enough space to write down, so I have to write above the write on the symbol. So you can just note it down in the books, and after that we will discuss the fourth pillar. Okay, so the fourth pillar is language. Okay, so language is the collection of strings. Okay, for example, language L might be look like this: A, B, A, B, B, A, B, and B, A. So this is the language, which is a collection of strings of length 1 or 2. So either length will be 1 or length will be 2. Okay, and it is finite. So language can be either finite or it can be infinite. So the above example depicts that the language is finite language. And what about infinite language? Let's take an example. Let's say L is length of strings greater than or equal to 2, and the possible alphabet symbol here is A, comma B. So the length may be start from A, B, A, B, and BB, and so on, triple A, triple B, and the length will goes on. So this is nothing but an infinite language. Okay, so the language is either infinite or it may be infinite. So what are the 4 pillars that required in theory of computation? The first is alpha symbols, which are the basic building blocks. The second one is the alphabet, which is the collection of symbols. The third one is the string. The string is nothing but sequence of alphabets. And the finally language, which is collection of various strings. Okay, so in the next video we shall start with the first part of the theory of computation, finite automata classifications. Okay.